Hey everybody, Dr. A and Dr. A Jr. here, and in this video we're going to be exploring an example of couple moments. But before we get started, let's go ahead and hit that like and subscribe button and be on the lookout for other content like this. Okay, we ready? I think we're ready. Let's get started.
In this example, we are going to be given a figure of a triangular plate, well, actually trapezoidal plate, with several couple moments acting on it, and we're being asked to compute the resultant couple moments. So let's draw this figure together. This is all given information. So we're going to have this trapezoidal plate. It's really like a rectangle with a triangular piece at the end. There we go. Actually, let me just put a little dash line there to show that that's where the transition to the triangle is. So let's put some dimension lines on this. This dimension right here, we're going to call this D1, and it equals 4 feet. We have a vertical dimension here, D2 equaling 3 feet. And then we have a diagonal dimension here, D3 equal to 5 feet. Okay, so let's go ahead and put our forces on here. We're going to have F1 is 200 pounds up in this top left corner. And then we also have this same magnitude F1 equaling 200 pounds right here. Okay, you can see that hopefully. And then we're going to have F2, 450 pounds, acting here. And then we have same magnitude, F2 equals 450 pounds, acting at this bottom left corner. And then we're going to have an F3 acting here, and the same F3 acting down here. And these are perpendicular to this diagonal. And because I'm kind of running out of room, I'm just going to write off to the side. F3 is 300 pounds. Okay, I'm just kind of a little out of room here and here to write it as nice as I would like to. So, so that's our figure. So let's figure out how we're going to get this resultant moment. All right, so I'm going to say the resultant moment, C sub r, okay, as a vector, is going to be equal to the sum of the couple moments in general. And we need to establish a sign convention. So we typically, for 2D, we say counterclockwise is positive. And what we're going to do is we're going to multiply these parallel forces by their perpendicular distances. So let's go one at a time, all right? Let's look at F1, all right? We have F1 here and F1 here, and the perpendicular distance in between the lines of action of these two F1s is 4 feet, okay? Remember, it's a perpendicular distance between the line of action. So you could think of it as like here is the line of action of F1 from here, and this is the line of action of F1 on the left side of the plate. So the perpendicular distance between them is this D1, all right? So we're going to end up saying 200 pounds times 4 feet. Now, notice that based on the directions of F1, of the two F1s, what kind of, forget about F2 and F3 right now, just look at F1. What kind of tendency of rotation is the couple moment generated by F1 causing? It's causing a clockwise tendency of rotation if you just look at F1, the two F1s by themselves, all right? So since that's clockwise, we're going to have a negative right there, okay? What about F2? What about F2? So forget about F1 and F3 now. Just look at F2 here and here, all right? 450 pounds. What's the perpendicular distance? Well, it's right here, 3 feet is that perpendicular distance. And if you look at how these are oriented, this is causing a counterclockwise tendency of rotation. So that'll be positive. So we're going to say plus 450 pounds times 3 feet, okay? And then what about the F3, the 300 pounds? So we have F3 acting perpendicular to this diagonal here and here, and it has a perpendicular distance of 5 feet in between. And if you look at how these F3s are oriented, this is causing a clockwise tendency of rotation, so that's going to be negative. So we're going to say minus 300 pounds times 5 feet. And so when we add all of those up, we're going to get this resultant couple moment equal to a negative 950 pound-feet. And you could write that as 950 pound-feet, and the negative would indicate it is tending to rotate clockwise. And that's your answer here. And that's it.